know what it means to be in the 99th percentile or something? And after we've got the count. Okay. Yes, George.
It means you're 99% better. You're like at that point and better than like the population.
Yeah, so if whatever is being tested or scored, if you line everybody up, if you were at the 99th percentile, you'd be 99 out of 100, okay, you'd be towards the top. Like if you took a standardized test, an ACT, an SAT, or some sort of test, and you scored in the 99th percentile, that's really good, man. That's really good because 99% of the people are below you, and there's only 1% that you're looking up to. Does that make sense? Now, the median, the middle number, is what percentile? Louder? The 50th, right? It's right in the middle. There's 50% of the data ahead of it, and there's 50% of the data behind it, okay? So the median is the 50th percentile. What's the lowest value? That's like the 0 percentile. There's nobody below that person. Right? If you get a standardized test and you're in the 0 percentile, that's really bad news. There's nobody below you. If you're in the 75th percentile, we have a name in statistics for 25, 50, 75. What do you think they would be called? What? Quartile. Quartile is great. If you're percentiles, but they're like elevated. They have more. They're more distinguished. They're select percentiles. They're called quartiles, right? Quarters. 25th percentile is the first quarter. 50th, which is it's got a lot of names. It's the second quartile. It's the median. It's the 50th percentile. But then the 75th percentile is the third quartile. And we talk about these things with, again, great respect because they kind of show us the shape of our data. When we get the min value, Q1 is the symbol or the notation for the first quartile. That's the 25th percentile, right? And the next thing is the median. This guy's got a lot of names. That's Q2 also. Another alias would be the 50th percentile, right? Q3, what's that? 75th percentile. And we have the max. Now in statistics, we call this group of numbers a 5-number summary. Now we know 3 of those 5 numbers right now, don't we? What's our mean value on our data? 61. That's 61. What's the max number? What's our median? 82, right? Now, we're not going to do it by hand, but if we were to look at our data, conceptually, how would we find Q1 and Q3? They're halfway between the 50th and then the one above the one below, right? So Q1, if this is essentially 0 and this is 50, Q1 is the middle number in that data set, right? Of the first half of our data set. It's the 25th percentile. Q3 is halfway between this one and this one, right? So it's just the halfway part, because this is the 75th percentile. Questions? Now you could do it and, you know, count them up, and it has the same rules. If you got an odd number, then you just take the middle one. If you have an even number between here and here, you'd have to go to the middle 2 numbers and average, okay? But Texas Instruments has been very kind to us. You see this little arrow there? It says scroll down if you want more information. So all that it's done is tell us what our five-number summary is. So our five-number summary is 61, 70, 80, 37, 104. For the first quartile, the 25th percentile for us is 76. 86 is our 75th percentile. Do I need to put these up here? 25th percentile, 50th, 75th. That makes sense to everybody? Everybody got that? Quartile, percentiles. Now, when we do that, we can create what we call a box plot. In a box plot, imagine we have a number line here, kind of imaginary, okay, going from 61, let's put 60 here, we'll put 70, put 80, put 90, we'll put 100 here. Now this isn't part of the box plot, this is just my really bad graphic I'm trying to draw it. So I want to draw a box plot. The first thing I want to do is go to the median, the 50th percentile. So that's at about 82. I'm going to put right there, about 82. Median, 82. I'm going to draw a box. I'm going to go to the left and go to the first quartile. So that's at about 76. Q1, 76. And let's see, I'm going to go to the third quartile, so that's at 86, so that's at 82. That's not quite as far. Labeling too big, I guess, here. We're going to get rid of that. Q3, 86. And that's the box. And in some cases, we call this a box and whiskers plot. So that's the box. The whiskers are going out now to the min. So I'm going to go out to 61. And I'm going to go out to the max of 104. And that's what's called a box and whiskers plot. So the box, we have the whiskers. And if you do it with some scale, better than I've done it, I mean, this you're not going to see. That's not part of the box and whiskers. That was just to help me put it. But you get a sense that how much of our data is between 76 and 86? What percent of all of our data is between 76 and 86? How'd you come up with that, Kyle? Great. It's high-level thinking, right? 50% of the data is right here. How much of our data is between here and here? Trick question. Between Q3 and the max, what percent of our data? 25%. Right? There's 25% of the data between each demarcation. And so it gives you some sense of how spread out the data, where the core data is, but it's called a box and whiskers plot, or whiskers plot. Questions? Okay, so the last calculation of the day.